Hello students, Eric Magidson here. This is part 2 of the solutions video for the basic functions lab. We're starting with the lookup formula. We want to return a bonus amount for each employee. It's based on their years, as we can see here. So I'm going to use the vertical lookup formula because the chart is formatted vertically. My lookup value is going to be years employed. The table array, I could just do this, but I like to always use the full table. I need to make that absolute so that it doesn't iterate down. I want to return the second column, the bonus, and I'm not going to find an exact match, so it's a close match, so I always type in the true. If I audited this first person, the lookup value would be 10. They should get $500. Looks like the audit's good. Just to reaffirm that I did the correct formula, I'll go down here. 17 years, looking at the chart, should return $1,000, and it does. Here we want to return the quota for each employee. So the quota looks like it's based on the number of years. The quota goes up as the employee works for the company more. So I'm going to say equals VLOOKUP. Actually, I should just come over here, do the VLOOKUP. Lookup value again is going to be years. Table array would be the same. Need to absolute that, but this time I want to return the quota, which is in column 3. And again, I'm not going to find an exact match, but a close match, so I'll return that. Indeed, at 10 years, the quota is 3,000. Put this down. It says using the above information, insert a formula in the blue cells that returns yes if the employee met the quota and no if they did not. So it sounds like an if function. We're testing for a true or false. That's an if function. If. The logical test. If this is greater than or equal to, because if they meet it by the exact amount, they've met the quota, correct? Equal to their quota, then we want to return the term yes. Otherwise, we should return the term you're fired, but we'll return no. Say okay. Arrow this down. And indeed, this person here had a 5,000 quota and only sold 3384, so they did not meet their quota. Let's go to lookup 2. Lookup 2 is going to return grades. I'll get rid of a couple of these blank columns here. There we go, so it all fits. It says return the letter grade for each student based on the table of grades. Well, the table happens to be in a horizontal format, so it's the HLOOKUP formula I want to use. I'm going to say HLOOKUP. Sorry, folks, it's pretty late. There we go, the logical test. Why did it? Silly. Let's try this again. HLOOKUP. There we are. HLOOKUP formula. The lookup value is here, the table array. Right there. Got to absolute that. The row I want to return, in this case row 1 is what we're looking up, so I'll return row 2. I am not going to find the exact match for 61.21, so I know I'm looking for a close match. Indeed, they should return a D. I'm going to fill this down. 98.6 should return an A, and it does, so I'm done. Here we're going to return the cash bonus for students. Looks like good students get some money, huh? Maybe that's what we need to do with the financial aid system. If you get good grades, we'll take a few bucks off what you owe. That'd be kind of cool. Would you try to get better grades if you had to pay less? So again, it's a horizontal lookup formula. HLOOKUP, it's right here. Lookup value is here. Table array is going to be the entire table value. Absoluted. This time I want to return row 3. 1, 2, 3. So I'm going to return 3. And again, I'm not going to find an exact match, so I'll return true. And indeed, a D gets you no cash. An A looks like it gets us 15 bucks. There's an A, they get 15 bucks. And just doing some auditing. Looks good. Here we're creating a link. It says create a link in the yellow cell that links to cell A82 in LPGA 6. We'll just do this. Hyperlink. Place in this document. Cell A82 on LPGA 6. Okay, let's see if it works. It indeed took me to A82 on LPGA 6. So there's my link. All right, some future values. Let's see how much money we're going to make. Future value. Complete each future value above. Looks like they're all monthly payments. Use GoalSeek on the last one, so we'll do that one last. But we still have to figure out the future value on it. I'm going to come up here, more functions, future value. Remember they're monthly payments, so I know I'm going to take the rate and divide it by 12. I'm going to take the number of periods, multiply by 12. The payment so that I get a positive value. I'll accept positive or negative values, but if I have you do subsequent calculations using the future value, this certainly makes it a lot easier. Payment is $275 a month. I don't have any present value. I don't have any type. There is future value of $61,000. By the way, folks, I'm just going to go ahead and copy that, paste it over. Widen it, paste it over, widen it, paste it over. I'll audit this last one. Future value, K3, divided by 12, yes. K4 times 12, and negative K5, 184. But we're going to do some GoalSeek here. It says change K7 to $1.5 million. By changing only the time in years. So how many more years do I have to invest at 10.22%? Invest $300 a month to make the future value of $1.5 million. I'm going to come up to data, what if analysis, GoalSeek. I want to change K7 to 1.5. Make sure I got the right amount of zeros. I do 1.5 million by changing only the time in years. There we go. We'll say okay. There's those railroad tracks. Don't leave those. Widen it. So I go from 18 years to 37 years. What does this tell us? Invest early, folks. You want more money? You know, we're investing for what? Double the time, basically. Getting a nice return. Now this one we have to be careful. And you want to make sure that you use some critical thinking and analyze the problem beforehand. This one is every other month, every 4 months, bi-monthly, and quarterly. So every other month, future value. I'm going to do the future value formula. Which means I'm going to invest $275 every other month. So my rate is that. How many times can I invest every other month in a year? That would be 6. Number of periods, 13 years times 6. My payment value, negative $275. If I invest $275 every other month for 13 years at 5 1/4, I'll make 30 grand. Every 4 months. Every 4 months, that means I can do that 3 times a year. Okay. I'm on it. Future value. The rate divided by 3. Number of periods. For 14 years, I'm going to make 3 payments a year, every 4 months. And the payment I'm going to make, 150. I don't have any other information. Now, that's not a lot of money, but it's 150 bucks that we're investing every 4 months. This one is bi-monthly, twice a month. I'm going to make a payment of 50 bucks. So every time I get paid, I'm going to put 50 bucks in the bank for 22 years at 6.75%. Let's see what kind of return I get. The rate, that divided by 24, time in years times 24, payment. Notice I'm not putting any static values except for these. Say okay. Wow, 60 grand after 22 years. Quarterly payment, which means quarters, 4 quarters in a year. Future value. The rate divided by 4. Number of periods times 4. The payment, 300. 60,472. Notice the difference here? Kind of interesting. Payment functions. Now we're going to borrow some money and make regular payments. These are all monthly payments, so I know I'm going to divide and multiply by 12. That's right. More functions. Payment is the PMT function. There it is. My rate for the first one is 5.25 divided by 12 for my monthly interest rate. Number of periods, in this case 1 year times 12, so I know 12 payments essentially. Present value, 2,000. My payments are $171.44. Now wait a minute, if these are all monthly, no changes in the rates, no change. Okay, that looks good. I'll just copy this, paste it in, paste it in, paste it in. Make sure I audit the last one. Looks like K4 divided by 12, K5 times 12, negative 1.2. That looks good. Make sure you audit it, because if you don't, and this one's wrong, and you use that shortcut or easy button of copy and paste, not only is this one wrong, but now all of them are wrong. So we want to make sure all of them are right, because we don't want to be wrong. Isn't there a song like that? All right, moving on. Last one. Now we're going to change the time periods. So for the payment, so here we go. Every other month. That means every other month I'll make a payment. I can make 6 payments in a year. Come up here, payment function. There's the payment function. My rate is that divided by 6. Number of periods, this, times 6. Present value. Let's see here. Every other month, 343. Every 4 months. So notice this time I cannot just copy and paste because the time frame is different. The rate, every 4 months. I can do that 3 times a year. Periods, 5 years. Amount I borrowed. So every 4 months I'll have to make a payment of $1,151 and some change. Bi-monthly, twice a month. Lost my train of thought. Rate 24. Time 24. Making 2 payments a month, the payments should be pretty small because the interest is going to disappear faster, correct? It's basically half that interest rate, half of a month's interest rate each month. So payment function. Quarterly, so 4 times a year. Rate divided by 4. Years times 4. Present value, current loan amount, $1,250. My quarterly payments are 18 grand. Anyway, folks, that's it. I want to encourage you, go back, study, practice, study, practice, study, practice, study, oh, sorry, broken record. But hopefully you're listening. Take care. Hope to see y'all in the study sessions.